Alright, let us look at another question in the chapter of triangles. This has to do with proving of similar triangles. In figure 6.9, if angle 1 is equal to angle 2 and triangle NSQ is congruent to triangle MTR, then prove that triangle PTS is similar to triangle PRQ. So looking at the figure, let us try to interpret what has been given. Angle 1 and 2 are equal, which means this angle and this angle are equal, as a consequence of which PS and PT are equal sides. Then we are told triangle NSQ, which is this triangle NSQ, and triangle MTR, which is this triangle. So these two triangles are congruent, which means their sides are equal, their angles are equal as well. Then prove that triangle PTS and PRQ are similar. PTS is this triangle and PRQ would be this large triangle. So we've got to prove them as similar. So let's write down the given data. Angle 1 is equal to angle 2, and we will write here what it implies. It implies PS is equal to PT. And the second piece of information given is triangle NSQ is congruent to triangle MTR. And we have to prove triangle PTS is similar to triangle PRQ. So let's begin with our proof. So first we say PS is equal to PT, and let's call this equation number 1, and the reason we give is angle 1 is equal to angle 2 given. The second statement we make is SQ is equal to TR. Let's call this equation number 2. And the reason we are able to say SQ is equal to TR is because we are told that this triangle and this triangle are congruent triangles, which means their corresponding sides are equal in length, and SQ and TR are their corresponding sides. So we say CP CT for triangle NSQ and triangle MTR. Now if I add both of these equations, I get PS plus SQ, which is equal to PT plus TR. This gives me PQ is equal to PR. Let's call this as equation number 3. In order to prove these two triangles similar, what I'm going to attempt, let's say this side and this whole side will bear the same ratio between this side and this side, and then I would be able to invoke the SAS rule of similarity for the two triangles to be proved similar. So now I'm going to say equation 1 and 3. If I divide PS upon PQ, it would mean PT over PR. That is one statement that I can make, because these two are equal and these two are equal, therefore the ratio of the left hand side would be equal to the ratio of the right hand sides. And now what I have shown is this side divided by this whole side is equal to the ratio of this side divided by the whole side. Those are sides of the two triangles we are trying to prove similar. And then we know angle P is common, therefore by side angle side rule of similarity, triangle PTS is similar to triangle PRQ, hence proved. Now let us move on to another question. Let's read this. Diagonals of a trapezium PQRS intersect each other at point O. PQ and RS are parallel and PQ is 3 times RS. Find the ratio of the areas of triangles POQ and ROS. So let's build a diagram representing the given data. So this diagram pretty much represents the data given. We have a trapezium PQRS, and we have been told that PQ and RS are parallel to each other, and PQ is 3 times RS, which means if RS is X, PQ becomes 3x. Now with this diagram, we would have to find the ratio of the areas of triangles POQ, that is this triangle, and triangle ROS, which is this triangle. So we have a theorem which will help us to solve this question, and the theorem basically states ratio of areas of similar triangles is equal to the ratio of the square of their corresponding sides. So using this theorem, we are going to calculate what is the ratio of the areas of the mentioned triangles. All right. So first let us consider the two triangles that are given. Consider triangle POQ and triangle ROS. The first statement we make here is angle OSR is equal to angle OQP. And what we are showing here is this particular angle is equal to this particular angle. And the reason is these two are parallel lines. Therefore, these two form alternate interior angles. So the reason we write here is alternate interior angles. Then we say angle SOR is equal to angle QOP. And these two angles form vertically opposite angles. Vertically opposite angles. Therefore, by double A rule of similarity, triangle POQ is similar to triangle ROS. But that is not what we have been asked to find out. We've been asked to find out the ratio of the areas of these two triangles. By this theorem, we know that the ratio of the areas of similar triangles is equal to the ratio of the square of their corresponding sides. Now, we do not know numerically what these sides are, but we do know the ratio. One is x and one is 3x. So we write the area of triangle POQ divided by area of triangle ROS is equal to, we can write the square of the side of POQ, which is PQ square divided by RS square, which implies 3x whole square by x square, which becomes basically 9 by 1. So the final answer is, therefore, the ratio is 9:1. And that is the final answer.